now I perform the experiment number 4 for the optical. This is the very important for the next coming year examination 2021. This is to find the focal length of a given convex lens, by the displacement method. I read out the theory. Here the two object pins are object pins and the image pins are kept on the optical bench separated by at least 4 times the rough focal length. Always maintain the distance between the object pin and the image pin is greater than equal to 4f plus 10 centimeter of the given convex lens. That is this x. This is the separation distance between the object and the image pin. Always greater than equal to this distance, 4f plus 10. And then for each reading at the two position, we remove the parallax and take the reading for the two position of the lens, that is L and L dash. And then you find the difference of these two readings, this is small d. And from this data, we ultimately put this value here, 1 by f equals to 1 by x plus d by 2, 1x minus d by 2. Ultimately, you will get f equal to x square minus d square by 4x. This is through the experimental value. And also, here we draw the graph. So, for this graph, we plot here the calculated parameter y equal to x square minus d square by 40 against the x, that is the distance between the two optical pins. And then we, from this graph, the slope of this graph, we find also the value of the focal length. So, to perform this experiment, at first you find the rough focal length of this convex lens. Here from any distance object you project the image on a plain paper or a sheet in such a manner, then you just measure the length of this image and this lens through a ruler, and then you find the rough focal length of this lens. So here you see, at first, in case of observation, you write in such a manner, at first to find the rough focal length f of the given lens by projecting the image of any distance object on answer script and then measure its length by the scale or the ruler. I find this is more or less 10.3 in the 3 case, 10.3, 10.2 and 10.3 centimeter. So on average this, we find this is 10.2 centimeter. So the required distance between the separation distance between the object and the image pin, it should be greater than or equal to 4f plus 10. Here f is the rough focal length. So you, after calculation, the distance should be greater than 50.8. So now we start this experiment in the optical bench, measuring the distance x equal to first greater 50.8, that is 60, 70, 80, 90 and 100. Now I set the pins, now I set the lens in the lens holder. Lens holder, here you see, always you kept object needle at the 0 cm centimeter mark, you should not move this object needle from the 0. It is very important part. And in the first case, the image needle at 60 centimeter mark. So this separation distance is 60. So x equals to 60, and in this case, at first, I see here there is no parallax to the lens at this position, that is L is 47.2, that is L 47.2, and then it is to the close to the object pin, it is 13.5. So here we see a blunt image. And this is the position L dash. So you see the difference, D equals to L minus L dash 33.7. In such a manner, I just shift the image pin 70 centimeter, 80 centimeter, 90 centimeter and 100 centimeter, kept the object pin always at the 0 centimeter mark. So the corresponding, I get there is the two position of the lens. One is very close to the image needle and very close to the object needle, that is 57.5, and 13 in case of a 70, that is 67.2, 12.7 in case of 80, that is 77.8, 12.4 in case of a 90, that is 88, and 12.4 in case of a 100 centimeter. So difference these two, I got the result D 33.7, 44.5, 54.5, 65.4, 75.6, and putting this all data here, this formula F equal to x square minus d square by 4x, where x is the this length, d is the this length, and 4 into x is the this length. After calculating all value, we get 10.2, 10.4, 10.7, 10.6 and 10.7 centimeter, and on average this is the focal length of the given convex lens through experimentally. Now to draw the graph, you should calculate this parameter y equal to x square minus d square by 40. You just put this value and calculate this value. You calculate in case of when the separation distance is 60 centimeter, y should be 61.6. When case of a 70, it is 72.9. In case of 80, it is 85.7. In case of a 90, it is 95.5. In case of a 100 centimeter, it is 107.1. Now I draw the graph. You see, this is the graph. Here I plot the separation distance x along the x-axis, and this parameter y equal to x square minus d square by 40 along the y-axis. Always you take the smallest division. In case of a x-axis, also in case of a y-axis, here I choose one smallest division along x-axis equal to 2 unit, and in case of a y-axis it is also 2 units. So this is 0, 20, 40, 60, 80, 100, 120 and so on. And in here this is 20, 40, 60, 80, 100, 120 and so on. Now I plot the data. In case of a 60, you see the reading. In case of a 60 centimeter, the calculated value of y is 61.6. So here you see, in case of a 60, this is 60, this is 62. So in between these two is 61.6. So this point is 61.6. So in such a manner, against the value of x, I plot the data of the y in this way, and then I join the data in a straight line of best fit passing through the origin. So maximum data will cover through this straight line. Now I take the two unknown points here to draw the gradient. So I drop the perpendicular here and then I join this. So you see here S equals to delta y, this is delta y, this portion, and this is delta x, this is y2, this is y1. So y2 minus y1 change in y, x2 minus x1 that is change in x. So y2 here you see this is 100 minus y1 should be this is 38 here. So this is 38 and x2 is the 94 and x1 is the 36. X2 is this is x2 94 and this is x1, this is 36 here, this point corresponding this point. So after calculation S equal to 1.06 and then the focal length using this formula F equal to 10 into S. So 10 into 1.06 it will be 10.6 centimeter, which is more or less equal to 10 centimeter. So from calculation part it is 10.5 and from graph it is 10.6. So it is a very important part practical for your coming examination. So there are some precautions here. You also write this practical in your lab copy. It is very very important for the coming 2021 examination. This is the complete this practical. Thank you.